Hi, Stefan. Today we want to talk to you about flares and vents. It sounds a slightly exotic topic. So can you tell us more about why gas flares and vents are such a problem? I mean, I kind of think I ought to know the answer, really. Clearly, gas, methane, has a whopping 80 times greater than CO2 in causing climate damage when it's measured over 20 years, say. And I kind of read in The Guardian as well that even to add to our worries, this, of course, might even be an underestimate due to multiple compounding effects. So methane emissions rising, agriculture, landfill volumes rising, and then now, to make it worse, due to global heating, it seems like with the natural increase of methane coming from natural places like wetlands and tundra, and even the wildfires that we've been reading about recently, that's actually reducing nature's capacity to mop up methane. I really do feel it's a problem, but I want to hear from you, again, what is the problem and how big is it?
Yeah. So let's look at Saudi Arabia, for example. And we're looking at the Gawar field here, which is the biggest in the world. And, somebody has set up a really nice data system called Flare Intel, where you can actually see the individual flares in that field, over, miles and miles and miles. And the picture here shows you what these flares look like. So imagine this picture over 50 miles or so, one flare after the other. And on top of that, what you can also see on this satellite image here of fugitive methane emissions is that the Gawar field is also associated with additional fugitive methane emissions. So that's something that you would hopefully also address if you clean up these flares. And I understand there's also a refinery here, but we start to get the picture that it's the refinery plus these incomplete combustion issues that you have with flares.
So looking at the map, flaring and venting seems to be quite a widespread problem then. And you're saying fugitive escaping emissions, they even compound the situation. So has this topic got much attention?
So flares and vents have always been a problem, but only since we have these satellite images, and they show the methane emissions, do we see the real extent of the problem. And the Gazra gas project is actually a great project that combats this. And personally, I don't understand why Shell doesn't take a victory lap on this one and does much more of this as part of their Powering Progress strategy. So Basra is one of the largest flare reduction projects in the world. It captures the methane before it goes into the flares from, three very big gas fields here, the Rumaila, West Qurna, and Zubair. And, takes it to that refinery, collects all the gas, obviously, and then converts it to liquefied petroleum gas, and then sells it. And Shell, instead of doing more of that, they currently focus on renewables and mangroves planting. And mangroves are fine. I have no problem with mangroves, but others can do mangroves much better. Whereas flares and vents are Shell's core business, as far as I'm concerned. And nobody can clean up flares like Shell. So that's what I'd like to see Shell do much more of.
Yeah, I mean, I took a quick look at the website, and it seems this project alone was cleaning up 38% of the previous methane emissions in Iraq. I mean, I know the website's a couple of years out of date now, but it's a pretty significant project. So what more could they do?
Well, they could clean up the remaining 62% for starters. But more importantly, the Basra Gas Company could expand its business model and be more efficient and profitable by using the CO2 to H2 process to create clean burning hydrogen from what's currently LPG. And LPG only defers the emissions to their customers as scope 3 emissions. Whereas with CO2 to H2, they just have to put an SMR plant, next to a nearby gas field, like the Suba field here. Some CO2 injectors to back inject that CO2 into that Suba field. And then they convert all of that, or the remainder, sell it as golden hydrogen, which actually has a much higher value than the LPG.
Yeah, I mean, it's quite a complex project there in that country. I mean, are there other big opportunities for fugitive emissions reduction with this process?
Yes. And this is Texas. And we're looking at the Permian and the Eagle Ford shales, which are currently the two biggest oil producers in the United States. So they have a very high gas-oil ratio, and small operators in the Permian simply can't afford to bring the gas to market. And, and they flare it. And if the wind blows out the flares, then it becomes a vent, which we can see here on the satellite image in high resolution. And Flare Intel is a very polite database, and the guys from Flare Intel call this incomplete combustion. I call it venting. And in Texas, you actually have these private flare chasers driving around the Permian and reporting, those blown out flares to the operator. But the damage is immense. And the regulator, quite honestly, does nothing to stop the venting.
And that's conventional gas, and you hear a lot about unconventional gas in Texas as well. Would this process work for unconventional gas?
Yeah. So first of all, for associated gas from oil wells and from unconventional gas, you need a nearby conventional gas field where you have to inject then the CO2 into. It's part of the CO2 to H2 process. And in the case of associated gas and flaring, you could buy the gas for pennies at the wellhead and convert it to carbon negative golden hydrogen. And by the way, LNG exporters in the Gulf Coast have a similar business model. But of course, they also, or mainly, export LNG from unconventional gas, which is produced by fracking. And our flow chart here is exactly the same for both cases, whether it's captured gas, associated gas from oil wells, or unconventional gas. We convert it to hydrogen and CO2, and the CO2 gets stored in a nearby conventional gas field. And since you ask about unconventional gas and LNG, this would be an option for Europe as well. That you can convert the methane to hydrogen before you put it through an LNG plant and freeze it for transport. And the UK has an interesting business model there. They actually import the LNG and then convert it to blue hydrogen with CCS in the UK. So they inject it into some UK assets, whether it's aquifers or empty gas fields. And first of all, that capture process isn't perfect. But the big question I have is, why do you import the CO2 in the first place if you only want to sequester it there? You could sequester it in Texas, have golden hydrogen, but that's a story for another talk if you like.
I think so, yeah. It's early days yet. I mean, going back to Texas, my understanding is indeed all these little companies, especially the little companies, are focused on oil production. And so the gas byproduct really, less value, less interest. But, why does it happen? Why don't they take advantage and turn this flaring of gas into an opportunity?
Yeah, and it's mainly due to the lack of regulations. governments and regulators could easily stop this practice. In the US, it's an issue between state versus federal law. And well, as we all know, Texas has a mind of its own, and I see no chance that they change their regulations anytime soon. In the Middle East, for instance, we looked at Basra. It's a state-owned companies, and they basically make their own rules, so they can do what they like. So until it's changed on a global basis, this presents a huge business opportunity for ESG investors and disruptors. If all companies become complacent about their core business. And CO2 to H2 provides a pathway towards profitable golden hydrogen production. But the benefit for the planet is even much bigger and can be estimated by just accounting for the CO2.
Sounds great. But obviously, Stefan, you know a lot about the opportunities, not about these places, especially oil and gas opportunities in Texas there. But if I was an ESG investor, I really wanted to be socially responsible as an investor, how would I go about finding opportunities in the region that I was interested in?
Yes, it's data science and visualization. So, we combine flare intel with satellite image data from the International Energy Agency, and also with a map of conventional gas fields. And that's the way we actually generate opportunities for golden hydrogen in any given region, even if we can't enter the country ourselves. So this example, for instance, shows Ukraine, where we see huge potential for a very big golden hydrogen hub. And we're currently working on this opportunity here. And 5 years ago, this wasn't possible when we didn't have flare intel or these satellite images.
Well, huge potential there, clearly, for golden hydrogen. Some challenging examples there as well. But thank you very much for starting to explain this great process. And thank you for your time.
And thank you. See you at the next talk.
Okay.
Now comes the tough part. Oh, here it is.